Hello again. Welcome to another lesson in Algebra 1. Today we are covering sections 3.1 and 3.2, solving one and two-step equations. All right, so warm-up says give an expression representing each of the following. And there was an example problem today. It said spend $50 per day for X days plus 230 extra dollars. How much did you spend? And our answer here was 50x plus 230. And notice the X goes with the 50 because we're doing that $50 every day, and X stands for the number of days. All right, number one, make $5 per hour for X hours plus 750. How many dollars did you make? So that's 5 times X. You make $5 for X number of hours plus 750 extra. Okay? So for instance, we could test this and say, well, what if I work 10 hours? How much should I make? So basically, if you replaced X with 10, this would equal to 5750, which is how much you should have made for 10 hours of work. 10 hours times 5 for $50 plus the 750 bonus. All right, number two, spend 65 cents per carton of milk or X cartons, and then you spend 80 extra cents. Okay, so maybe you bought everybody in the family a carton of milk, and then you bought yourself a coffee or something. All right, plus 40 miles per hour for X hours, and then go 70 miles further. So 40 miles an hour for X hours, and then 70 more. So let's say we went for X hours, and that'd be 40 miles per hour. So that's 40 miles over hours. And then that's times by maybe 5 hours, and then plus 70 more miles. So remember, these hour units are going to cancel out, so we would end up with 40 times 5 plus 70. Okay? All right. Fly 600 miles per hour for X hours. So 600 miles an hour for X hours plus 1,000 extra miles. Okay? Earn $6 per an hour for X hours plus pay back 10. So paying back is going to be subtraction here. So subtract 10. My first job was, my second job in high school was at McDonald's. My first job was a paper route as a younger person. And at McDonald's, I made about $3.25 an hour. And at the end of the first week, I had to pay back for my uniform. So I had to pay back 10 of the dollars that I had made. Okay. All right, so solving one and two-step equations. When solving any type of equation, the goal is to isolate the variable. That is, in the end, we want the equation to look like x equals some number, or it could be m, or whatever the variable is. And the steps to do this, once again, are number one, locate the variable. Number two, notice the operators that are being done. We have addition, subtraction, multiply, division. Those are the only four we're worrying about right now. And then you undo these operations by applying the operations to both sides of the equation one at a time in the opposite order. So we want to do the opposite operations. So opposite of addition is subtraction. The opposite of subtraction is addition. The opposite of multiplication is division, and division's opposite is multiplication. Okay? And then we're going to apply these in the opposite of the order of operations. So we're going to apply grouping symbols, exponents, multiply, divide, and add and subtract in reverse order. So we're going to start with first add and subtract. And then we're going to go to second, multiply and divide. Okay? And then we should really check our answers by substituting back in. I do not require a written check, but you do have to do it for other problems where I just say, is this a solution? And we've been practicing this all along. Okay? All right, number one, 10 equals 2b. So our inverse operation would be to divide both sides by 2, the opposite of times by 2. And we would get b equals 5. Now, to the joy of many of you, I do not require you to show this inverse operation. So algebra 1 now, we know what inverse operation we're doing. We are doing divide by 2, so we get b equals 5. Okay? This was a one-step equation, so it needs one line of work. Number two, we have a addition by 3 as our operator that's being done, so we would undo it with subtraction by 3. And negative 12 subtract 3 is negative 15. Number 3, we have a subtraction operation being done and a multiplication operation being done. So subtract 6 and times by 2. We'll undo the subtraction first because we're going in reverse order. So that will make 11. And then we'll undo the Multiplication second, so we'll divide by 2 to get 5.5. Okay, this one has two lines of work because this was a two-step equation. I did not have to show the inverse operations in between, but I do need to show that 2x equals 11 line. Number 4, I add 3 to both sides to get 0. And 0 and decimals like number 3 are all good answers. Please don't get freaked out if you get an equation and the value is 0. Okay. So within number 5, we subtract 16 from both sides. We'll get negative 14 as 2x. And then we undo the multiplication next, and we'll get x is negative 7. Okay. Now the reason why we subtracted 16 is we needed to get rid of a positive 16 here. So 16 minus 16 for 0. So be careful. A lot of people miss number 4. Our first step here is to subtract 12, which will give us negative 8 equals negative 2x. The subtract 12 takes care of the positive 12 here, and then this negative 2x is left behind. Okay. Then I divide by negative 2, and I get 4. Okay. Oops, x equals 4. Notice these last two problems had two lines of work, and that's because they were two-step equations. Number 7, we divide both sides by 5 to get negative 2. That's a one-step equation. Number 8, we subtract 5 from both sides to get c is negative 11. And number 9, we add 9 to both sides to get negative 4 is x. Okay? Circle all of our answers here. And then one more time, go back and circle in blue. Problem number 1, problem number 2, problem number 4, 7, 8, and 9 were all one-step equations, which means they only needed the answer for their line of work. And problems number 3, 5, and 6 were two-step equations. That means they needed two lines of work. Okay? All right, so I already told you we've been doing the checks all along, and I really suggest that you at least do a mental check here. So like for number 1 there, we had 10 equal 2b, and we wanted to check if 5 was an answer. Remember, we put 5 in here, put a little question mark, and then we find out that the left and right are the same, so we knew that 5 was the solution, so we did it correctly. A lot of times you'll see me just take this side, and on my calculator I'll do 2 times 5, because 5 was what b was, and I make sure it makes the left side, which was 10 in this case. Okay. All right, using reciprocals. This is a little trick in math when we have a fraction next to the variable. So it's times by a fraction. The easiest way to get rid of it is to multiply by the reciprocal or the multiplicative inverse. And we spent a good bit of time talking about this in chapter 2, what those are. Okay, so if I times this side by negative 7 over 2 and this side by negative 7 over 2, these two fractions times together to make 1, and 1x is just plain old x. And then on the other side, we have negative 28 divided by 2, which is negative 14. Okay. Same thing in number 11. I'll times both sides by the reciprocal. 6 over 5, or the multiplicative inverse, whichever you want to call it. 60 divided by 5 is 12. Times the tops, the 10 and the 60, and then you divide by 5. Okay. And in our last one here, we're going to times both sides by the multiplicative inverse. Negative 4/3. And we're going to get m over here. Okay, and on this side, 9 times negative 4 makes negative 36. Divided by 3 makes negative 12. Okay. Combine like terms first before finishing the solving. So the 7 and 8x are on the same side, so we combine them to make 15x. That's 7 plus 8 and put the x back. Divide both sides by 15, and we're going to get x equals 2. And number 14, we're going to combine these together to make negative 4d. That's 5 minus 9. And then we're going to divide both sides by negative 4 to get 4 equals d. Number 15. Okay. Notice in 13 and 14, I did have two lines of work. You need to show both of them. Number 15, the output of a function is 5 more than negative 2 times the input. So the output of the function is y. Is my equals, and then we have negative 2 times the input, that's negative 2x, and remember more than switches the order, so it adds a 5 to the end instead of in the beginning. However, if you put the 5 in the beginning, it doesn't change your answer. So this is my equation for the function. That was the first answer it asked for, and then it said use your equation Use your equation. Please don't just give me a final answer here. To find the input when the output is 11. So I replace y with 11 because that's my output. And then I subtract 5 from both sides to get 6. And I divide by -2 to get -3. So this is the input that makes the output of 11. Number 16, the output of function, which is y again, is 4 less than 4 times the input. There's 4 times the input. Here's the less 4, and that's my first answer. And my second answer says use my equation to find the input when the output is 3. So the output is 3, and we want to find the input. So we add 7 to both sides, or add 4 to both sides to get 7. And then we divide by 4 to both sides to get 1.75. Okay. All right, we have 2 more problems, although next one kind of combines a couple problems into one. Okay. All right, a scuba diver descends into deeper water. The pressure of the water on the diver's body steadily increases. So as you go farther down, there's more water pushing on you. That's why you feel the pressure in your ears when you go underwater. Okay. The pressure of the surface of the water is 2,117 pounds per square foot. So even though you don't know it, 2,117 pounds are pushing on every square foot of your body. Okay? We just get used to it where we don't know it because we feel it all the time. So the pressure increases at a rate of 64 pounds per square foot for each foot the diver descends in the water. So we get extra pressure as we go down. Okay? So write an equation P, given it some depth D. Okay? So P is my output, and my input's got a D in it, and the D goes with the 64, because every foot down we get 64 more pounds of pressure, and we always had that starting value of 2,117. Okay. Use your equation to find the depth at which the diver experienced a pressure of 8,517. So the pressure is 8,517. We set that equal to 64D plus 2,117. Subtract 2,117 from both sides. We get 6,400 equals 64D. Then you divide by 64, and you get 100 is D. So we got this. The diver is 100 feet deep. Okay. There's one more question about this on the next page. This time the diver is 5,317 feet deep, or has this much pressure, I'm sorry, and we want to find out how deep they are. So 64 times how deep they are plus 2,117. I subtract it over, I'm going to get 3,200, except I didn't write that. So 3,200 equals 64D. I divide both sides by 64, and I'm going to get 50. Okay, so the diver is 50 feet down. Okay. All right. Kate has a job where she makes $8 per hour plus tips. Write an equation for the total money Kate earns T. That's our output because it's as a function of some other stuff. So T is supposed to be a function of some little h for the hours she worked and a little t for the tips that she earned. Now we'll look back in the first sentence. She makes $8 per hour, so that's got to go with the h. Okay, so 8h. Plus she gets some tips. Notice I put a little curly on the end of that t there, and that's so I don't confuse it with a plus. Okay, and then our last one here, we know she made 53 total dollars. And we want to figure out how many hours she worked, but she also got $13 in tips. So now we've turned it into a two-step equation. Subtract 13 from both sides, and then divide by 8, and we find out that she worked 5 hours. So Kate worked 5 hours. Okay, there's a follow-up today. It's 5 questions down below. The answers, final answers are on the bottom, but please make sure you show work, which is all of these equations up top have 2 steps of work to show, and then you have to write and solve an equation down below. All right, I'll see you in class next time.